technologies and build practical models using Google's powerful TensorFlow library. We all know how busy you are from your academics, and Saturday is your rest day, but you still manage to come here and learn something new. We hope you'll find this event both insightful and enjoyable. Now, are you all guys ready for today's event? You may spam the reactions to show your excitement. Thank you everyone for sending your reactions. I'd also like to extend a warm welcome to our participants joining from media partners. We have from Bohol, we have GDSC, Bohol Island State University, GDSC Crystal E College, and GDSC Holy Name University. And from Cebu, we have GDSC Cebu Institute of Technology University, GDSC University of San Carlos, and GDSC University of San Jose Recoletos. So we're delighted to see participants from Luzon and Mindanao as well. Please let us know in the chat where you're joining us from, whether within the Philippines or even abroad. So you can type in the chat where you are watching from, You're, whether you are from Cebu or from Davao or Manila. So we have Laguna, Cebu. So please note that we can only accommodate up to 100 people here in Google Meet due to its maximum capacity. So for those who cannot enter here, we have on Discord also. Don't worry, you will not miss out the fun. You can still send your questions in the Q&A session later. So we have from Capiz, Bohol, Cebu. So shout out to all of you guys. We have from Bohol, yeah, Laguna. So here is the program flow for this afternoon's event. First, we did a quick hello and introduction. Next is a short icebreaker. And next is the formal main of the event. We have the introduction to machine learning with TensorFlow. After that, we'll have a quick photo opportunity and a Q&A session after. So please take note that this meeting is being recorded for future reference and will be uploaded to the GDSC CTU YouTube channel. So to create the best experience for everyone, please keep your microphone muted, and this helps minimize background noise and distractions. And please feel free to keep your camera off. And the chat feature is a great way to ask questions, share thoughts, and participate. And last is just enjoy. Our goal is to create an informative and engaging meeting. Sit back, listen, and enjoy the presentation. So, but before we proceed to the main part of event, let's break the ice first with our short icebreaker. So, this is called Guess the Animal, Wrong Answers Only. So, I'll show you a picture of an animal, but with a twist. The real answer is actually hidden somewhere within that question mark. So, you may send your answers in the chat box. So, the first one is this. You may send the answer in the chat box, guys. Fish, kangaroo, bird, whale, elephant, dog. So no one got the correct answer yet. It starts with a letter G. Giraffe, close, close. G and O. Gorilla. Yes, that's right. It's gorilla. The correct answer is gorilla. The next one is this one. Yes, we have Donny Mark Mendoza. That's right. It's a cat. Yes. And the next one is pig, flying fish, dog. Yes, that's right. Curvin. It's a dog. And the fourth one is this. It's a rat, hamster, monkey, bird. Close. Starts with letter C. Yes, it's a chicken or a rooster. But last one is this one. Horse, elephant, duck, shaked, horse. Okay. It starts with letter D. And a clue is it's extinct. Frog. The word dinosaur. Yes, that's right. It's a dinosaur. So, just like this game, machine learning algorithms often start with incomplete information. They have to guess and analyze patterns to identify the correct answer. So, whether it's an animal in a picture or a complex data trend. So, thank you everyone for sending your answers. I hope this gets everyone in a playful mood for the rest of the event. So now let's move on to the main event. So today, we're honored to have a tech leader who blends innovation with practical application. With a focus on cutting edge technologies like generative AI, his accomplishments include leading the development of a Gen AI powered knowledge hub at Trip Guru. With a foundation from the Wharton School of the University of Pennsylvania and postgraduate studies in innovation at the Asian Institute of Management, his journey is marked by his insatiable curiosity and relentless pursuit of innovation. Beyond tech achievements, his role as a co-founder of Datos Pilipinas and Veripol reflects his dedication to using technology for societal benefit. Now, he will share insights on introduction to machine learning with TensorFlow, promising a practical guide into the world of machine learning. Please help me welcome Mr. Gerald John Velarde. A virtual round of applause, please.
Hi. Hello. Okay. Ivan, should I proceed with my talk or will you ask a question first? Wait, sorry. Oh, yeah. Okay. So before we proceed, I just want to know what comes to your mind when we say AI. What's the first app that comes to your mind? Like, can you join this Slido so we can build a word map? Okay. I see some chat GPTs. That's great. Can you actually answer it here? Just gonna give the team a couple of seconds to join. Um, yeah, to join, you just need to scan the QR code. I just want to get a general feel. Yun, two participants are typing. Okay? Yan, people are joining. All right. I see ChatGPT, Gemini, Bing. Hmm. Gonna give the team like 30 seconds before we move on. Prediction tool. Nice. What about tools? What about apps na ginagamit nyo day to day? What do you think about when we say AI? Like, take a look at your phone, tingnan nyo yung top apps that you use, and take a look at what do you think uses AI here predominantly? I see Alexa, Google search. All right. Claude, Okay, I think this is quite the insight now. And as you can see sa word map natin ngayon, yes, napaka-dominant ni ChatGPT ngayon, no? See some notable apps here like Photoshop, Grammarly, Alexa, TikTok, that's nice. TikTok and Facebook. All right. Later on, gonna give you guys an understanding, or at the very least, show you an overview of the industry that it's not just chat gpt despite how prominent it is nowadays. So let me just share my screen, and before we proceed, don't worry, chat gpt is very very prominent, and honestly it's what got me into ai once again. um just looking for my screen. Okay, let me know if you can see intro to tensorflow. Okay. I'm very, very excited to do this talk with you guys. I'm seeing some familiar names, a lot of new ones. So before I proceed, I'm just going to give you guys a quick overview of what we're going to discuss today, starting with setting your expectations and introducing who I am, demystifying AI. What is it actually we refer to when we say artificial intelligence, introducing TensorFlow and the magic of this wonderful library made by Google Brain, and building your first machine learning models, and then later on evaluating and improving your ML models. All right. So before I proceed, I don't usually introduce myself, but in this particular talk, I think it's very relevant to share my journey and how I got to this particular point in time. uh, movie pause moment, ganyan. So my journey actually started using TensorFlow and AI technologies. This was way back before ChatGPT was prominent, and I think the latest hype around AI at that time is computer vision. It's been very dominant in the space for the past 10 years or so, since 2012 at ImageNet. I built a project. This was for academic purposes, but generally an app to classify a skin lesion, basically skin abnormalities, whether it is benign or a malignant cancer. So it's a classifier basically. Back then, I used BGG16. BGG16, it was fairly new at that time, and I used TensorFlow, and it introduced me to my career, and it set me up for um, what I'm very grateful for right now in the space of uh, technical product leadership. But as you might have noticed, my background doesn't really align your typical AI speaker. I have more of a business background and more of a leadership background, quite that far from your typical developer. And um, hopefully, at the end of the first part, I'm gonna share a little bit more of why that is, and hopefully inspire a couple of you to invest into tech according to your interests. So after I built this particular project, unfortunately, I realized that AI was quite expensive to get into. It wasn't quite as accessible as it is today, despite the advancement that there was. But there wasn't, there weren't really people hiring like fresh grad back then at the level of where it is right now, and a fresh grad or even people with no experience to build your own AI models and whatnot. It's more of a corporate use case than a startup experience. And as someone who was hungry growing up, I gravitated to the highest bidder. So I built my own startups and started with AI. We wanted to like build like a ML machine learning model rental service, basically something like Hugging Face nowadays. And it didn't work out, but I learned a lot. We pivoted a couple of ideas, and somehow it landed me into a product role. I worked as a product designer and then transitioned into a product manager. But that wasn't my first paying job. After my experience in startups, it taught me a lot, and we built a lot of great things here. And if you are still getting started in the industry, I do suggest you take a look at what startups can do for you. So my experience there led me into gave me an opportunity to work in corporate business intelligence. I never fathomed that this industry even exists, but generally I was building data pipelines for multinational conglomerates. So think of billion-dollar brands in the Philippines, food manufacturers and whatnot. And I was part of a team to develop their data pipelines portals around business intelligence. It showed me the scale of data and its power, its impact across the industry. And I'm very grateful for that experience. However, I was also looking for a more hands-on and more involved experience rather than uh, what I was feeling at that time. So I joined a startup in the Southeast Asia. It was called, and I joined as a technical product leader. So combining my experiences throughout my past opportunities from product design to AI engineering to like my understanding of software engineering, I somehow got into a technical product leadership role where I interacted directly in the middle of developers, business people, and designers. So I'm in the middle of primarily everything happening around innovation and technology for our Southeast Asia startup. So generally, we're building what Grab is, but instead for drivers, it's for tour guides across Southeast Asia. And we're very proud of our work. And I wouldn't have gotten here if I didn't got into tech through TensorFlow and AI because, despite me not landing an opportunity in that area, it introduced me to how technical things can be and what you should and how should you make an impact and the different roles in the industry. I'm going to share a little bit more about that later on, but generally this is my story so far. um, I'm a lifelong learner that values both theory and practice. I'm going to show how how we've done that in the past year. I am a firm believer that AI will play a major part in everyone's lives in the next 2 decades at the very least. People predict that it will automate jobs in the next 5 to 10 years. I'm a bit more, I want to say, realistic. From my understanding of the industry of how capitalism works and innovation works, I'd say it's at the very least 10 to 20 years for the laggards to adapt AI. However, um, the adoption of generative AI so far has been very good. I'm going to share a couple of slides on that later on. But when ChatGPT uh, came into popular culture, I realized that hey, something's kicking up. Before I left AI back then in and joined startups, I shifted from computer vision to NLP and got very dismayed about how slow the progress was in natural language processing compared to computer vision. s- Somehow I know how important natural language processing is at that time. I just didn't know how to make an impact there. Now with ChatGPT entering popular culture, it's a lot easier to build stuff, and my passion for AI has been rekindled. So in the past year, we've just been building projects left and right. I started building alone with my 100 AI projects powered by AppGen. If you guys know Synth, they built a couple of tools that would enable you to create applications at the application layer of the technology stack. So I identified like I was looking for 100 use cases and trying to solve them with generative AI, from writing letters to creating personas and even creating problems that my own AI would solve. Like, for example, I was writing personas for agents to assume, like, hey, I want to talk to Leonardo da Vinci, and here's like the script to assume like how Leonardo da Vinci talks. And I wrote like an app that automates that particular task for me. So creating problems that I myself will solve. And somehow I'm gonna touch on that later on. But here I realized how powerful AI is, and when something when we loved an idea, we gather with a group of friends and we continue building on top of it. So we joined a couple hackathons, built in public, try to solve not really for let's say corporate use cases, but just for passion. When you know the saying that when you have a hammer, everything looks like a nail. Well, we have a very shiny hammer in 2023, and we were just trying to hit everything with it and figure out the use cases. So somehow my understanding of the technology, or like this effort both on the theory and practice side, led me to understand the technology faster than my peers in the product space or in the industry in general. And with my understanding built from my experience there, I actually applied it to my work. And now this is corporate use cases where we actually saw some data. I can publish some metrics or say where exactly it was used. But generally, we built a system where engineers will interact with generative AI and marketing professionals. So the problem there was there were a lot of stories stuck between engineering that weren't communicated to our leads and customers, leading a trap in value. So when I was tasked to like help unblock this particular hurdle, we took a look at, hey, what are the stories we can tell and what's the typical process. So I did an access to be process analysis, and then I realized that we have a lot of stories to tell in engineering. What's stopping it from uh, reaching our customers? And honestly, it's just getting past that blank white page, and it's a lot easier to edit than to create. So what we did there is we crafted a multi-layer prompt system where we start with ideas with a lot of human intervention. So starting with ideas, then to what is promising gets developed into a draft, and what is gets endorsed into engineering. And with that, we were able to actually make some impact. It was very fun seeing numbers grow and seeing our work being communicated to our leads. It's a very rewarding experience to see to apply something very new and see the impact of it in your work. So that's what got me hooked in innovation. And with that experience, I landed another role in the Southeast Asian startup that I mentioned, and we had a different problem here, and it's around increasing the efficiency and reducing the search for information times in the operations department. So I took a look at the problem and realized that, hey, there are a couple problems here that we should solve, starting with centralizing the database. And after centralizing it to one format, we need a way to interact with it. So includes tools that enable us to search specific, not just keywords, but phrases in entirety. And with the advent of AI, we also have a very intuitive, low cost to build question and answer tool. So you can now ask questions to your database, and that has provided us with a lot of value, both in inspiring the team to do a lot of the tedious work to make this happen, and actually getting the value after that. So with this, I got invited across the country to speak about generative AI. Um, through practice and theory, I was able to understand the technology faster and apply it and like see some results. And somehow that opened up some gates. And in 2023, I did a tour Luzon and Visayas and Mindanao, and it was very fun and very rewarding to talk about generative AI. And my promise here is that at this talk, you'll have a better understanding of the field of artificial intelligence, where you can provide a value in, and what are the things happening in this field in 2024. An understanding of how to build your first TensorFlow model, TensorFlow machine learning model, and how to address issues and improve the ML models that you create. So ultimately, the goal of this entire talk is to introduce you to this wonderful field of AI, and hopefully, you discover what role you gravitate towards and make an impact in it. So let's get started. The first part of this talk is to demystify AI. Before we begin talking about TensorFlow, we have to establish a firm understanding of what artificial intelligence is. And I've structured this talk into three core topics. First would be industry, taking a look at the industry at large, and then data representation. How does our AR model actually see information? And then the anatomy of a model, like the basic building blocks of a neural network. So when I did a search for this talk, there were a lot of ways to classify AI. Some were actually quite new to me that I realized are decades old already. So in this particular graph, you can see type 1 and type 2, but this is just a subset. This is just like a snapshot of it. There are other ways to classify AI. But generally, type 1 is more of based on scope of AI, how powerful or how capable the AI system is. And type 2 is more of the functionality of AI. Just gonna do a quick overview of what this is. But generally, narrow or weak AI is designed for specific AI tasks and like what mentioned, Alexa, Google, Alexa, I saw someone say Google search as well, recommendation systems, but this system lacks to beyond generalize the tasks beyond its training. So it's narrow and it's a specific use case, but it's we're already seeing a lot of results from it. Majority of the innovations in AI up to this date is still around narrow AI. Companies have formed to build general AI or and super intelligence, but unfortunately we're not there yet. Or fortunately, we don't know what its impact in the industry is. But what these two are, it's basically general AI is a theoretical concept aiming for human-like intelligence. So capable of understanding, learning, and applying knowledge across a wide range of tasks. So not just the task that it was trained in, but a wider range of tasks. It's no longer narrow and it's more general, as the name suggests. Super intelligence is the next step after general intelligence, where general intelligence aims to match our human intelligence across a wide array of tasks without explicit training. Super intelligence exceeds human intelligence in problem solving, creativity, and basically just name it, it should exceed it. Type 2 is generally reactive, limited memory, theory of mind, and self awareness. I'm not going to go deep into this, but similar situation with type 1. Most of the innovation happens in the first two types within reactive machine and limited memory. A couple of notable examples here for reactive machine is that Deep Blue's chess playing machine, IBM's chess playing machine called Deep Blue in the early 2000s. So it's a reactive machine. It doesn't have a life of its own. It reacts to human input. Limited memory learns from past data and makes decisions. So recommender systems, predictive analytics, prescriptive analytics, and majority of the innovation falls into either one of these two. Theory of mind is basically something that aspires to human-like decision making. Still under development and no impact there, no major impact there. More of a research field to date. Self-awareness is similar to general intelligence, but here we envision AI with a human level consciousness. It's capable of understanding itself, basically. Um, yeah, quite the task, and kudos to the people working in that field. But yeah, it's generally not for me. So what I'm primarily interested in is this particular subset of AI. So I created this graphic just to illustrate what is and what isn't. So AI is a broad field. Generally, it just is um, basically saying it's a field to emphasize our efforts around building machines that mimic human behavior. And people say, hey, that's not AI, that's too dumb and whatnot. But even if else statements or symbolic AI, um, there's another term for this. It's good old fashioned AI when I was studying back then. It's still classified as AI. Is it that good? Depends. There are some great innovations there as well, but it's not what people usually think about when you say AI. Machine learning, on the other hand, is systems designed to learn from data without explicit rules. So in artificial intelligence, there are systems that require rules, like rule-based systems or logical reasoning systems, and that's still part of artificial intelligence. But machine learning as a subset is more of a we're not going to give you the rules, we're going to give you the data, and you need to look for the pattern within that data to predict the rules. So that's the general idea around machine learning. Deep learning is a subset of machine learning focused on deep neural networks. Basically, we're going to show a graph on that later on as well, but it's a field design with deep neural networks to capture and model complex patterns. So it's so some components here: convolutional neural networks focus on vision, recurrent neural networks for time series data, and transformers for text. And then lastly, the golden child of this family, which is generative AI. So far, none have seen the adoption rate similar to generative AI, but generally, it's just an AI system that focuses on creating new content. Some key architectures here, primarily like ChatGPT, are under multimodal architecture, where you have different a system of architectures working together to serve the needs of the user. And then when I was still active, GANs were quite the thing. And generally, you can see it's basically a predictor and descriptor model, sorry, a discriminator model. And someone creates and then someone like one model creates, one model tries to analyze if it's like the real data. And I think that has laid the foundation for um, the current generative AI, the form that we know of today. Of course, you can't mention like generative AI without transformers and BAEs, which are the core components for um, the technology behind ChatGPT. However, um, why should you care about machine learning? Uh, the hype around AI, you see, like when we did the word graph, there like the top thing that people know about AI is Chat GPT. So why should we care about machine learning? Again, going back, machine learning is the broader set of things where we also like have decision trees, linear regression, and support vector machines. Um, where people are generally focused around AI, and in you can see in my story before we got started, I'm actually just focused on generative AI as well. I mean the application layer. So why should we even study machine learning at this point in time when you see like wild valuation across the industry from billions of dollars to the recent 7 trillion request from OpenAI, and even McKinsey's post about uh, AI is generally around generative AI. Well, if you look at the industry at whole, you can see that the value from AI is still from supervised learning, which is despite the wide attention that generative AI was able to capture, supervised learning still trumps and still is the king towards value in AI. I'm gonna share a little bit more about that later on, but generally from time series prediction data to um, computer vision to recommender systems, or like majority of the innovation is still on supervised or semi-supervised learning, which is basically labeling stuff and then uh, asking a model to predict what's the pattern within the data and try to self-correct itself. And generative AI is still a budding field in the space. So in the grand scheme of things, you can see it in the past predictions. This was before ChatGPT became into popular culture. This is from Gartner, um, predicting how much business value can be created with generative AI. So from use cases like decision support augmentation to agents and decision automation, $2.9 trillion have already been predicted just with this technology alone. And Deloitte, here are some key use cases of AI from intelligent automation, cognitive insights, fueled innovation, and transform engagement. Generally, I'd say the recent advancements in generative AI just made it easier to do intelligent automation, or that's what most people think as of this moment. And that leaves a lot of space for machine learning and the AI, machine learning and the other different models for different use cases around artificial intelligence. So, um, and another key reason why you should learn machine learning is that if you analyze the layers of AI, this is what I mentioned earlier by application layer, is that if you learn machine learning, you go deeper in the layer. So just a quick run through here, infrastructure layer is cloud, think of GCP, AWS, Azure. Data layer are data companies, or the data that companies own, like think of the data that Google or YouTube has on its users, or third-party providers like data brokers. Next is the model layer. Think of companies like OpenAI who are focused not just to creating products like ChatGPT, but also in furthering like our understanding or like the cutting edge of the model architecture. Lifecycle layer or ML ops, a subset I would say of the infrastructure layer. Um, and then lastly, the application layer. The projects that I shared at the start of the talk are just in the application layer, and we're able to do a lot of things thanks to the advancement in generative AI. So, as mentioned earlier, we just made it easier to do intelligent automation, and now we don't. What basically changed in the past couple of years is that a lot more new use cases can be done under the application layer. But that doesn't mean, but if you learn machine learning, that means you go deeper in the layer and you can provide more value in this particular stack. So if you take a look at the companies, this is from Forbes, the AI 50, there are some applications in the application layer, character AI, chat GPT, um, Tome, and some key applications here. Generally, building on top of uh, existing or like popular artificial intelligence models. Then there are some infrastructure companies here. OpenAI as the company that developed ChatGPT is also here. Somehow it's in both Hugging Face, Weights and Biases, Llama, Databricks, and these companies. If you learn machine learning, you go deeper into the layer stack, and you can provide more value towards the companies in here, not just in the application layer. And another key thing here is that if you further understanding of artificial intelligence through machine learning, you become more valuable in the application layer as well, not just in, let's say, where you typically think about learning TensorFlow or uh, learning TensorFlow or Keras or machine learning. You typically think about just staying around the model layer. But no, your understanding of AI makes you more valuable in the layers above as well. And this is a analysis of the jobs in the space the past 2022 and 2023 by McKinsey. And you can see, although although like there's a move towards an ease of hiring, people are hiring more, are able to hire more people now. It's still a lot difficult to get it. It's still like there's still a scarcity in the talents in the AI space. So as I mentioned earlier, like it's not just machine learning engineers. I myself, I'm under like the AI product owners or managers, and you can see like the different roles that you can take into by learning in the wonderful space of AI. So just it's not just like being a machine learning engineer, and yeah, even my job as a product manager, I benefit greatly from understanding AI, not just at the application layer, but also understanding the ML ops and how do you actually build machine learning models. All right. So with this being said, I hope this sets the field on where AI is currently. And so far, what we've discussed is the broad field of AI, the different types of AI from the classification based on capabilities and function, from the different types of learning, uh, from the different types of uh, the different subsets of artificial intelligence, um, why you should learn machine learning, not just generative AI, and the layers in the AI industry. Now we go into the second part of demystifying AI, data representation. How does AI systems actually see data? So I, I created this short example here, but generally imagine a light bulb that turns on or off if you have a value of 1 or 0. So 1 it says on and 0 it says off. This is scalar, so this is like a number. Um, and if we expand this analogy to like three light bulbs turning on or off, you now have a vector. Now, if you expand that into a grid, you'll have a matrix. So typical uh, things you learn in your math class in college. And now we're gonna discuss what tensors actually are. So tensors are multi-dimensional matrices. So imagine that. So we started with a light bulb into an array of lights into into a grid of lights. Now we have a fundamental of how a fundamental analysis of how AI AI sees pictures. So imagine imagine it's not just one particular channel. Like in a typical picture, you have data around that picture. So it's like to control color basically. So you have red, green, and blue values, RGB values. If you played around tools like Figma or Photoshop, you'll see that you can actually tweak these values directly to control your canvas and uh, to control your canvas and the picture. So we can see here that these lights are off and these lights are on, and we can see how do I say this, a figure taking place. Any guess to what this is current what image this is of? Can someone chat in the comments? Yeah, just a quick question while I drink water. Guess what, if this is was a picture, what would it be? Can anyone guess? Number one or seven. Great, but wrong. Introduce videos and you'll have someone dancing. Supposed to be a short joke, but generally, yes, if this was a short picture, it should be a one. But to show multidimensionality, you're not just limited in like four channels. You can also introduce the dimensions in time and frame rate. So with that, you started from a light turning on and off, and now we have a picture down to a video. So that's basically the fundamental of tensors, multidimensional matrices. Here's snippets from the documentation of TensorFlow about tensors. Don't worry about the link or the key details here. Yeah, it's part of the resources that we'll share after this talk. So here's a key properties you should care about when you're handling tensors. So what's the shape of the tensor and what's the rank? Um, Similar to the analogy we created earlier, a scalar, a number of shape, turns a vector into a matrix. And into that matrix, you can expand into many different dimensions. It becomes tricky at this part, at rank 4, because basically it's 4 dimensions, and it's very hard to visualize 4 dimensions in your brain. Um, and once you get to rank 3, sorry, I'm going to backtrack a bit. Once you get after like 2 axes, you can now uh, ref- you can now visualize the data in different ways, basically. So um, is 3, 2, and 5 similar to 5, 2, and 5, 2, and 3? Or if you jumble the numbers around, would it matter? Generally, you can argue that it doesn't, but it messes everyone up. So uh, the best practice here is start with the global values first and then to the local values last. So let's say this is a uh, these are the 4 properties that we have. You start with the batches and then the height and width and then the features at the last, the most local part. It's while these axes can be referred to their indices, you should always keep track of what is the meaning of each so that you can refer to and communicate it and use the data accordingly. Um, okay. Next is AI anatomy. What are the core components of an artificial intelligence uh, or a neural network, artificial intelligence neural network? So the first building block here is a neuron node. So after the data part, like the this is the core component of layers and networks that we're going to discuss later on. So we primarily have 3 key parts. However, there are still activation functions and summarization function. I separated that to another slide. Generally, the input where we don't do any computation. It just takes data in, and it has to be the shape of the data that we're taking in. It could be like from raw data or from the previous layers or of previous neurons in the previous layer. So the next part is the weights and biases. This is what we train when this is what we play around with, or the parameters that we train when we train an AI model. And uh, anyway, don't worry about the details here. I forgot to show one slide here, but don't expect you to understand everything here if you're new to the space. So layers is basically a collection of neurons that uh, make up the architecture for artificial neural networks. So input layer and output layer are the core fundamentals for machine learning, and hidden layers is the key ingredient for deep neural networks. It can be as simple as just one hidden layer or hundreds to thousands. And that's basically what separates deep learning from machine learning. It's like the depth of the layer, hence the name. Then functions, activation function after calculating the weighted sum. This is basically what enables like the model to learn complex patterns. If you think about the node as a linear regression, uh, as a linear regression formula, you'll be very limited. And activation functions is what enable the model to learn very complex functions. Loss functions is what we use to measure how well the training is performing, and then optimizers is how we um, gravitate to the desired output. So some key examples here is stochastic gradient descent and Adam function. Model architecture. Some basic model architectures you should know. There's sorry, before that, let's discuss machine learning paradigms. We've discussed earlier like the different subsets of AI. And then there's another classification of AI, which is how your AI system learns from the data. So as shown earlier, supervised learning, this is basically systems that learn from labeled data. So spam detection or as shown earlier, this is where majority of the value from business currently is. Unsupervised learning, where we give data to a model and ask it to uncover uncover the patterns without the labels. So clustering dimensionality and finding associations. And then reinforcement learning. Actually, this is one of the for me one of the most interesting parts of AI, where you just have a agent play around in an environment and you give it a reward function, and it would maximize that reward function. So think about it like a like a video game character trying to maximize the score. That's like a core fundamental of what reinforcement learning is. And of course, it's being used for video game AI, robotic navigation, and control. So if you've seen like the popular innovations from Google Brain, like the hands, uh, there was like a video of like hands playing around with virtual Rubik's cubes. Those were like uh, those were like the innovations under reinforcement learning. So neural network structures. Again, this is a bit this is going to be quite a lot to take in if you're new to the space. But generally, I don't want you to care about the details here now. You have convolutional neural networks primarily. The core advances in the technology in the architecture here is that it uses um, convolutional layers and pooling layers, where we reduce the data needed to learn the patterns around the uh, to learn the patterns from the data. So that's basically what it is. We use convolutional and pooling layers to reduce the data needed to understand the patterns in recurrent neural networks and transformers. So recurrent neural networks are basically for time series data, or where order matters, and transformers, the key component of the recent advances such as ChatGPT, is similar to recurrent neural networks, but order doesn't matter. So if you go into the field of AI with trying to understand everything before you build, it's going to be very inefficient. So this is why Andrew Nung, if you take his courses in Coursera or Deep Learning, or follow him in social media, you'll constantly hear him saying these lines: "Don't worry about it if you don't understand it." And I'd like to build on top of that. If you're building something, don't worry about it if you don't understand everything, like the core technologies behind it. Just build it and make an impact. And how do you navigate a space like AI without understanding the technologies? Because it's very tempting to dive deep into one part uh, and like fail to grasp at the whole. So I use this functional understanding of the components of AI. So instead of trying to understand like the end-to-end architectures, if you're coming from the application layer like me, it's best to think about what's the function, how can I think about this in a functional way. What are convolutional neural networks, what's its function in the general scheme of things. It's like, driving a car without understanding the engine. I don't need to fully understand the innovations around the engine, from the conveyor belt to the differentiator, and I just need to understand the functions of the steering wheel, pedals, and indicators. So if you're getting into AI, try to understand what those are and play around with it. So earlier I've shown like the architectural innovations of convolutional neural networks, recurrent neural networks, and transformers. The functional understanding of it is that convolutional neural networks are primarily used for processing grid-like data, such as images. So its core strengths are reducing the number of parameters needed to learn the data, as we shared earlier. So same with recurrent neural networks. The functional understanding here is that it's designed to process sequential data, and time series data. The core strengths here is that well suited for tasks where order is of relevance or is important. So think about forecasts or even the early use cases in text generation. However, we found that transformers excelled better than RNNs in natural language processing tasks, as evident as seen by like how powerful ChatGPT is. It's basically used for natural language processing tasks, and the core strengths here is that it allows you to do translation tasks, text summarization tasks, and question answering tasks. And that line of thinking is primarily what TensorFlow is built on top of. So a functional thinking and the goal, I think this is a great segue to the next chapter, which is the magic of TensorFlow, how TensorFlow can help us. So what is TensorFlow? Before I play a video here, TensorFlow is an open source library created by the Google Brain team. And Andrew Nong founded the Google Brain team, by the way. And generally, it was designed to make it easier. It's a library of functions to make it easier to create ML models. So let me just play a video here to show what TensorFlow is from TensorFlow. Can you hear the audio? Can you show me a thumbs up? You can. All right, perfect.
TensorFlow is an open source, end-to-end platform for machine learning. It provides a comprehensive ecosystem of tools for developers, enterprises, and researchers who want to push the state-of-the-art of machine learning and build scalable machine learning-powered applications. TensorFlow is designed to help you learn to build models easily. With an intuitive, easy-to-use set of APIs that makes it simple for you to learn and implement machine learning, deep learning, and scientific computing, it provides you with a rich collection of tools for building models. These include data pre-processing, data ingestion, model evaluation, visualization, and serving. But it's not just for building models. You can easily train and deploy your model anywhere with TensorFlow. It's designed to be highly portable, running on a variety of devices and platforms. It can scale from a single CPU to a GPU or cluster of GPUs, all the way up to a multi-node TPU infrastructure. So it's simple to build models that work on any platform, taking advantage of the power of each. TensorFlow also allows for powerful experimentation. With the flexibility to quickly implement state-of-the-art models, TensorFlow can power your research into new techniques to solve novel problems.
These include diagnosis of diabetic retinopathy, helping rural farmers spot diseased plants, and predicting extreme weather conditions.
With fast debugging and the ability to apply state-of-the-art ML models. And to top it all off, TensorFlow is driven by a worldwide community. This community is open and diverse. TensorFlow derives its roadmap from the needs of its users, with a vision to provide a machine learning platform that's for everyone. You can learn more about TensorFlow at tensorflow.org.
All right. So some of the key things mentioned in the video, it's not just for machine learning, it's also an end-to-end platform. So from data processing to data serving to hosting, training, and deploying it, down to scaling it up to your use case. Okay, I promise that it's not just going to be a purely theoretical talk. We're going to do some TensorFlow action before we end the talk. But just to establish what TensorFlow is, here's a key example of how you can play around with neural networks. So you don't need to understand or like code this manually nowadays. You can just call like the functions from TensorFlow. Like from what you can see here, this is a neural network for a task that classifies sorry, I forgot to add the data set here, but it classifies it to assumes 10 classes in the data set, and this is a convolutional neural network with three convolutional patterns and two max pooling layers. So with that, the goal here is to make it easier to develop and design your machine learning model architectures similar to like the functional similar to what we shared earlier, like the functional part of things in uh, build on top of the functional understanding, and then you can play around without having to develop the core uh let's say without having to dive deep into like a PhD in like the history of AI and like the structure so far, because AI is a, in the words of Andrew Nung again, AI is a very fast moving pace, and um math should not block advancements or people from making impact in AI. And I think that's one of the core values of TensorFlow. So, all right, I've been talking a lot. It's time to do some actual TensorFlow work. So let's go ahead and get our hands dirty and build our ML models. So let me just reconnect here and share the screen. Okay, can everyone see TensorFlow? My collab sheet. Can people give me a thumbs up? Okay, perfect. All right, so let's get started. So let me just restart the session. So let's see it. So let's build our first machine learning model. It's a simple single neuron model to predict salary after graduation. So we're we're gonna assume that this is a uh, we're gonna assume that there's a relationship between years after graduation and monthly salary in thousands. So here's our data. We're just gonna import TensorFlow and NumPy here. We're gonna load our data. If you can see here, this is the years, and this is like the monthly salary in the thousands. And our model here. So we're just gonna use a simple linear regression model. So our input size is one, our units is one, and our input size is one. Input shape is one, and optimizers is stochastic gradient descent and mean squared error. And then we're gonna train the model. Basically, this function says fit x into y and look for the patterns for 500 epochs. So just gonna train that model, and we can see the loss decreasing as we increase in iterations. So to visualize this, let's do a visualization here, and yeah, we can see uh, uh, let's say a healthy graph here. There's a function that you can call to stop like the epochs training, because if you can see, if you notice here, you explicitly state how many epochs you want the model to run, and not like the performance that you require of the training set. So it's more of like trying to go in blind. And if you want to just have a satisfactory level of performance, there's a function for that called callback. And but yeah, let's explore it later on. Now we go ahead and to predict. Let's show it new data that it hasn't seen before. So 6, 6.5, and 8.20 and 10 years after graduation, and then its predicted salary. Um, Let me just plot this data here, and we can see a simple model, linear model that plots it accordingly. Now, congratulations. At this point, sorry, I forgot to share the slides. I forgot to share the screen. Don't worry, I'm gonna share this after the talk, and it's not just gonna be a simple neural. Um, Congratulations, we've built our first machine learning model with TensorFlow. And yeah, just Just a quick rounds of applause there to appreciate it. Where I go down to classifying images, sharing the tab here, and okay. Now we go towards a computer vision example. So we're gonna go with an excerpt from Google where we use machine, where we're gonna classify clothes into 10 particular classes, and just to showcase the data here, this is basically around 60,000 images that are size 28 by 28. So let's start with loading the dataset here. It's part of Keras' training databases here. And okay, so to take a look, I made it simpler here. Basically, we are mapping the classes into numbers. The reason for this is uh, this might mean different things across different languages, and it's a lot easier to train it with assigning a number to it as a class and then using that to train the model and predict its output. So no worries here, basically just loading the class names here according to this table, and let's pre-process the data. So this particular activity is I'm still here, and that's weird. Okay. Um, just to plot the data here, the data set outright is the pixels are in the values of 1 to 255, 0 to 255, 0 being means it's not turned on, there's no data there. To 5, there's uh, there's a lot of data there basically. So what we're gonna perform is we're going to compress the data to a range of 0 and 1 by dividing it by 255. So this is standard image encoding for black and white images. And the reason why we're doing this is basically similar to like the normalization reasons of machine learning. So it's basically faster convergence, numerical stability, and to be able to train the model faster. Uh, Make it learn the patterns faster without having to play around with data from 0 to 255. Here are another couple of reasons here, and just to check if the data is accurate, we're gonna plot the data here, and yes, this looks like a top, and I don't see anything explicitly wrong with the data. This is a sandal, and this is an ankle boot. So we've done our first pre-processing the data, and now we're building the model. So take a look at the model here. We now have three layers. One to flatten the data into the input shape 2828, and then two dense layers with the hidden layer and activation function for ReLU. So sorry, I forgot to discuss that in discussing tensors, but the reason why you can argue that tensors or matrices are equivalent despite the different ways of visualizing it is that the total number of elements or units in the graph is the same. So the way you get that is by multiplying the indices or multiplying the dimensions of the shape. So if you have like a 28 by 28 input, it's 784 pixels of the range 0 to 1. So if you're interested in learning more about the different functions here, you can expand on the optimizer function, loss function, and metrics in the same sheet. And then we're going to use the Adam optimizer here with a sparse categorical cost entropy to classify the output into the 10 classes. So let's train it. Let's train it for 10 epochs and see its performance. In retrospect, I should have run that before I started explaining the model. Anyways, so you can see the model here going to 10 epochs, and we can see uh, the loss value decreasing, which is a healthy sign, and then the accuracy should increase as a counterweight to it, and just give it some time to process, and then later on we're gonna visualize what how our model predicts the data. Okay, last two epochs. Epochs basically mean a complete run through from all of the training data. So how many iterations there is. Uh, um, so by saying 10 epochs, we basically iterated through the training set 10 times. With that, we can proceed to evaluating its accuracy. So we're going to discuss like evaluation methods later on in when we return to the slides, but generally it's right now let's evaluate the test accuracy here, and we get an accuracy of 88%, which is not bad for something that just trained 10 epochs and just has 3 layers. So now let's use this to make predictions. Just going to load the data here and test images. We are using a softmax functions, which is basically plots like a sigmoid function across different categories. What do I mean by that? So it's predicting predicting the value of each. It's giving you a confidence level for each class for that particular input. So let's say we're predicting item 0, which is I believe a shoe. Uh, and it's going to predict it across all of the classes here, and that's what a softmax function does. And max prediction plus labels, some of it's preloaded here. I should have refreshed it. Anyway, um, let's do a visualization of this so it's a lot easier. Let me just throw it here, and yeah, so 9 it should be an ankle boot. Yeah. Basically, to show the data here, this is what we predicted earlier for item 0. It's ankle boot, and it's very confident that it's an ankle boot. So what the softmax is, it predicts a confidence level across the different classes. And in this particular example, we have 10 classes, which basically means if you use a softmax function, it's going to give you a percentage of how confident it is that it belongs to that particular class. So you can see that it has 99% for the ankle boot and 1% for the sneaker, which I'd say it's very justifiable. However, one key thing to note here is that um, it can be very confident despite being wrong. So it's predicting this input as a sandal, where it's actually a sneaker. So it's giving a 50% confidence rate for sandal, and a small amount for the right value here, which is sneaker. So again, what are these numbers? These are the labels that we've assigned at the top of this example, and basically, uh, what this says is it's predicting it to be a sandal when it's in fact a sneaker. So let's run it across multiple examples. Let me just refresh the data, because if you train a model, it's quite randomized at each time, so you might not get the correct data. You might not get the same results if you run and rerun this particular example again and again. You can see that it's performing quite well, where we can see it's guessing correctly for majority of the tasks, very confidently as well. It's not like a competition. Like this is like 100% a sandal, 100% a sandal, 99% a t-shirt. Or we can see that it can be quite confident as well, despite being wrong, guessing that this is a sandal when it's in fact a sneaker. How do we know? We do have labels in the training and test data. So this is an example of a supervised learning, supervised machine learning um, system. Now, let's use the trained model to make predictions across different images. So basically, if you build the model, it's now like you want to deploy the phone. This is basically its equivalent. Let's use the model. And yes, generally trained to run across a batch or collection of examples at once. So it's very handy that TF-Keras is built that way. And let's predict the output for the image. And ta-da! Sorry, I failed to visualize it here, but generally it guessed it correctly as a pullover guess. Okay, so that's our first machine learning model examples, and hope you've learned something or playing around with the data set here. There's an optional activity down at the bottom. Let's say, because we know in the ideal example, yep, thank you for a round of applause. And we know that you can't really just guess like uh, the salary of a person just by their years post graduation. There are multiple layers there. So if you have extra time, you can explore this particular model. It's performing quite badly, and try to think of ways of like improving its architecture. So again, the link will be shared uh, after the talk, right? So let me just share my slides again as we move on to the next part of the demo. Okay, so what we've done so far is we've discussed what TensorFlow is, what are the core functionalities and values behind TensorFlow, and how should you navigate AI as a beginner, as someone who's just getting into AI. How should you think about the core concepts to progress in the field? So again, there are many ways to kill a cow, and there are many ways to get into AI. However, if you're very new, I suggest you try to think about into functions, and having TensorFlow as part of your toolset would enable you to progress much faster than doing this all by yourself, which is I don't think anyone should do anyways. So another key TensorFlow use case here is before we proceed to how we evaluate, we just play this video. It's from TensorFlow. It's basically they use TensorFlow and Keras to transcribe medieval text. And
consultare documenti storici, soprattutto documenti medievali, richiede sempre molto tempo, molta pazienza. In Archivio Vaticano abbiamo 85 km lineari di documenti, più o meno la lunghezza del canale di Panama. Le scritture scritte nel Medioevo sono diverse da quelle che noi conosciamo. Se qualcuno mi chiedesse un giorno di trascrivere e tradurre tutti i documenti dell'Archivio Vaticano, sicuramente gli direi che è un matto.
Looking at this book, page by page, and trying to decipher, read, and transcribe whatever is there takes an enormous amount of time. You would require an army of paleographers.
What I'm excited the most about machine learning is that it enabled us to solve problems that up to 10-15 years ago we thought unsolvable.
In Codice Razzi è nato da quest'idea di costruire un software per poter interpretare, per poter leggere quello che è scritto dentro i manoscritti. Quando abbiamo iniziato ad approcciare il problema ci siamo resi conto che una soluzione basata su reti neurali fosse assolutamente necessaria. La scelta su TensorFlow è stata abbastanza naturale.
Before using any kind of machine learning model, we needed to collect data first. You have thousands of images of dogs and cats in the internet, but there's very little images of ancient manuscripts. We built our own custom web application for crowdsourcing, and we involved high school students to collect the data. I didn't know much about machine learning in general, but I found it very easy to create a TensorFlow environment. When we were trying to figure out which model worked best for us, Keras was the best solution. The production model runs on TensorFlow layers and estimator interface. We experimented with binary classification with fully connected networks, and finally we moved to convolutional neural network and multi-class classification.
In poco tempo siamo riusciti a sviluppare e a testare le prime soluzioni.
When it comes to recognizing single characters, we can get 95% average accuracy.
Poter accedere a uno strumento informatico abbrevia notevolmente. sciogliere certe abbreviazioni, comprendere un testo in quella scrittura così criptica è un qualcosa di eccezionale.
This will have an enormous impact. In a short period of time, we will have a massive quantity of historical information available.
I just think solving problems is fun. It's a game against myself and how good I can do.
Lo studio della storia è importantissimo per comprendere il nostro presente e per avere anche una prospettiva per il futuro.
I love this example in particular because it shows the potential of AI, not just a corporate tool to maximize profit, but also to preserve culture and shows you how machine learning is in action. If you are like tuned in into the at least the meme space of for AI, you see that there are people hired as machine learning engineers that they actually are just like data engineers or processing data and whatnot because it's a real problem. In this particular example, you can hear that uh, one of the core challenges that they face is the readiness of data. So as mentioned by the architect there was that um, there's a lot of data set around uh, cats and dogs online, but there's so few around something that we actually need in this particular example, which is there's not big of a data set for like medieval text that they were trying to translate. So what they did to circumvent that challenge is they I joked around this as like uh they use child labor to solve the problem. They if you heard about in the talk, they built a web app that they asked high school students to label their information for them. And honestly, that's a common approach. And I hear stories about my peers that they ask their significant others or their or their brothers and sisters, and they pay them money to like label stuff for them. And I think this shows how powerful supervised learning is, and it's a lot more effective to pay someone to label data to uh, solve to make it easier to learn patterns from it. And that's why supervised learning is so prominent. And if you see, this is why like the data labeling industry or data fulfillment industry is quite big in the Philippines because it's quite cheap and we need there's some infrastructure in place for that one. Basically, people are just labeling data so that they can train machine learning models on. One great example there is CAPTCHA, where I'm not sure if you guys are familiar. CAPTCHA or reCAPTCHA, the one where you select how many boxes or traffic lights. You're basically helping them create a data set to train their machine learning models on, while also serving the purpose of them identifying if you are a uh, robot or if you are a robot or if you are a script navigating the page or if you are a human navigating the page. So it's an I like that example particularly to solve that data problem in both ways. It solves one problem and solves another at the same time. So overall, what we've discussed is the general field of AI, just a checkpoint of where we are. General field of AI down to what TensorFlow is and core values around TensorFlow, and then the next part, which is building your first TensorFlow models, which included a simple linear regression model where we guess the progression along the line, and another one is the computer vision example where we classify images to 10 different classes um, using a uh, a deep neural network with a hidden layer in between. So if you're new to the AI, don't worry about the little stuff. And if you're building something, don't worry if you don't understand the core technologies behind it. Build it, learn about it end to end. This field changes very rapidly, and I in what in ways that what in ways that we should utilize technologies like TensorFlow to get us up to speed and make an impact and learn as we go. That's a crucial part in the journey. Okay, now the last part of the talk, which is improving performance. I'm running a bit out of time, so I'm just gonna breeze through this. But generally, let's say we have that model, we have that particular performance already, and we want to improve our grade, our score. In the industry, there are acceptable performance metrics like 99.9%. It really depends on the use case for the model that you've created. But generally, let's say you've built a model, you've trained some data on it, and you're not satisfied with the results. What can you do about it? So you start with choosing the right metric. You can't. This is not a one size fit all field. Different models are not built in the same way. So you identify the different metrics that you should have for the specific model you've built, whether it's a classification model, regression model, clustering model, time series model, or if you built an NLP model itself. So there are different particular metrics to um, gauge the performance of your system. And this is the first part. The next part is addressing overfitting. So one of the common pitfalls in machine learning is overfitting. This is basically when your model learns the noise in the training data. So it maximizes on the training data. And when you show it unseen data, it performs very poorly. It's one of the most common challenges in machine learning. How do you know if you are overfitting, if your model is overfitting? Basically you can see a high performance in the training data but very poor performance on the test data. You have like 99 or 100% accuracy on the training data, but when you use it on the test data, it's performing very poorly, like 50 to 20%, or something like very far from its performance in the training data. So the model has captured the noise in the training data and is maximized on it. Now, what can you do about it? So how to avoid overfitting? You can just generally use more data. You might be using too few of a data points to plot out, to understand the complex pattern within the data. And that's one key useful way to improve the performance of the model. It's just data. Another part is applying regularization, and we've shown a an example of that, or at least a baby example of that in regularizing the value from 0 to 255 to 0 and 1. But this is more of in the context of multiple different features with different values. One is in the range of 0 to 1, another is like 0 to 1000, and that gives it different weights unnecessarily. Next is simplify the model. Fewer parameters, the simpler the better. Cross validation and early stopping. Underfitting, also early stopping, is more of like you've trained it for too long. Underfitting, on the other hand, is that when your model is too simple that it's useless. So you have a too simple model, and when you show it new data, it fails to capture. It fails to perform when it's shown new data, but it also fails to perform on the training data. So how do you know when you're underfitting? It's basically, when you fail, you have like poor performance in both training and test data. And how do you address underfitting behavior? It's to increase the model complexity. You have your model is too simple. You need to add more layers or more depth there, or learn from the cutting edge of the industry here. Feature engineering, you might be using useless data. Let's say you're keeping track of years after graduation, but it's not statistically related to like the salary after graduation, and basically you're using the wrong feature sets or using the wrong data points. I'm gonna talk a little bit more about that in improving. And then last is reduce regularization. You might have regularized too much. The the third pitfall, or last pitfall I'm gonna share in this talk, is the data quality and relevance. So the phrase garbage in, garbage out applies in machine learning. So if you have bad data, you're gonna have a bad output. So two qualities here is like the science here is like your data set contains many missing values, it's incomplete or incoherent, And the other part is that you're using features that don't make sense with the desired business outcome. So this is why we have an entire team in like building machine learning models as shown earlier. There's a lot of roles here. It's basically we also need to develop domain expertise and business acumen. What features are related to what particular outcomes? What are the statistical correlations there? There are studies among that field. That's great, but if it's more of a niche business use case, you might need to do and find that relationship yourself. Which data is relevant to the outcome that you need? Data cleaning, feature selection, and data augmentation. So it's basically around those ideas. And then the next part is improving your ML model, which is basically the concepts that we discussed earlier. How do you address the top three pitfalls? Basically, improve data quality with more data, clean your data, and use relevant features for the data. Ways to do that is to look for statistical relationships or correlationships between data points, or talk to domain experts and subject matter experts. Hey, that data, and you'll get some qualitative insights around the data. Yeah, that might have caused this and whatnot. So both qualitative and quantitative insight helps in feature selection. Um, Next is, after cleaning your data, feature selection and transformation. Check what features you're tracking, reduce the dimensions of it, and then normalize, standardize your data. Then recap in 100 seconds of what we just discussed. So for those of you who know Fireship or those in AI already, what I've discussed uh, might have been familiar to you. And this is just a 100-second recap of what we've discussed around TensorFlow.
TensorFlow, an open-source machine learning framework famous for powering deep neural networks with high-level code. It was developed by the Google Brain team and first released in 2015. It's most commonly used with Python, but can run in other languages like JavaScript, C++, and Java. At its core, it's just a library for programming with linear algebra and statistics. As you know, the word tensor describes a multilinear relationship between sets of algebraic objects within a vector space, aka a multidimensional array. What makes it special is its collection of APIs for data processing, visualization, model evaluation, and deployment that make deep learning accessible to the average developer. It's extremely portable and is able to run on tiny mobile CPUs or microcontrollers with TensorFlow Lite, can run in the browser with TensorFlow JS, while the core library can scale up to multiple GPUs or run on tensor processing units, chips engineered specifically to run TensorFlow at a massive scale. It's used in medicine for object detection in MRI images, by Twitter to sort your timeline by tweet relevance, by Spotify to recommend music, by PayPal for fraud detection, in addition to many other applications like self-driving cars, natural language processing, and so on. To build your own neural network right now, create a Python file and install TensorFlow. Next, we'll need some data like Bash and MNIST, which we can automatically import. The goal is to train a model that can predict the clothing type of each image. TensorFlow has a subclassing API for expert users, but also integrates with the beginner-friendly Keras library, which has a sequential API that can easily build neural networks layer by layer. We start with a flattened layer that takes the 28 by 28 pixel image as an input and converts it into a one-dimensional array. This input layer is then fed into a dense layer with 128 fully connected neurons or nodes. You can think of each node like its own linear regression. As each data point flows through it, it'll try to guess the output and gradually update a mapping of weights to determine the importance of a given variable. In this case, it uses a rectified linear activation function that will output the input if a certain threshold is met, otherwise it will just output 0. And the behavior of this layer can be customized by tuning its hyperparameters. Finally, we have our output layer, which is also dense, but is limited to 10 nodes, which corresponds to the total number of clothing types in the dataset. Now we can compile the model and tell it to optimize a certain loss function, like sparse categorical cross entropy. As we train the model for multiple epochs, its accuracy should gradually improve. The end result is a model that makes a prediction with the likelihood that an image is a certain type of clothing. Congratulations, you just built a neural network. This has been TensorFlow in 100 seconds. Hit the like button if you want to see more short videos like this. Thanks for watching, and I will see you in the next one.
Perfect. So basically our sample in TensorFlow. So just a quick recap what we've discussed so far. It's the field of artificial intelligence is not just limited towards machine learning engineers. There's a lot of different roles in the space. Um, Generative AI is part of the popular culture, but there are a lot of arguments on why you should learn deeper into the stack in machine learning. And we've also discussed the different layers in the industry. We've also walked through like what is TensorFlow and what are how does it help us understand how does it help us build machine learning models and make an impact with the, and then we've also built our first machine learning models, one which is a simple linear regression and another which is a um, image classifier for the fashion MNIST dataset. And then lastly, we've also discussed how to improve your machine learning model when it underfits, when it overfits, and when you don't have the right data. We might be using the wrong features and whatnot. Hopefully, we'll be able to give you some value here. And here are the resources in the top, and we'll be sharing it with you as well. I'll be sharing it to the organizers. All right. Um, that's pretty much. Oh, sorry. Before I proceed and give it back to the organizers, I'm gonna wrap up my talk. I'm not gonna beg for money, but I'm gonna ask you something, just not financial. If uh, it's more of like, can you help me improve my talks? And love to get hear what you think about this talk so far. Share share a little bit more about uh, the scale of 1 to 5, how relevant and engaging what it was, and a couple of suggestions how we can improve um, in this particular talk. I really value your insight. All right, that's pretty much it, and I'm passing it over to you, Ivan. Oh yeah, this is my LinkedIn. Just gonna send it over. Please feel free to connect, and if you connect today, I'm gonna register that as you're from this talk, and I'm just gonna accept it, regardless. So yeah, please send me an invite. Ivan, back to you. Ivan, I can't hear you. Is it just me or?
Uh, hello, hello.
Hi.
I'm sorry, sorry. I'm audible na, sir.
Yeah, yeah, we can hear you.
Thank you, thank you. So, thank you very much, sir, for sharing your knowledge, and that was such an insightful talk. Diving into the world of AI and machine learning. So, I know that was such a, I can say, an overwhelming but an educational one. So, it will take time, months, or even years to master, uh, master AI, and just like in any other field. So, yes, there will be a Q&A after. So, let me just share my screen. This one. And now, as a sign of appreciation, Google Developer Student Club, Cebu Technological University is hereby awarding Mr. Gerald John Velarde, founder of Datos Pilipinas, for giving their time and knowledge during the introduction to Machine Learning with TensorFlow workshop organized by the Google Developer Student Club's Cebu Technological University, given this 23rd day of March 2024. Signed by yours truly and Ms. Jamaica Cavalida, and I am requesting the documentation team to take a quick photo opportunity with Mr. Velarde. Uh, Alex, are you here na?
Ah, yes, wait lang.
Sige. So, pause ka, sir. So, smile lang. Una, narabay.
Okay, ready.
Uh, three, katsa.
Yes, yes. Pero may mga reaction. Okay na, sir?
Sige, good sir, good sir.
Okay, thank you.
Then, next one is, let's have a quick photo opportunity with everyone. So if you'd like, you may turn on your camera for documentation. So let's just wait for others. And you may utilize this meeting background if you'd like. Uh, s- let's just wait for others. So I think most of us here have turned on our camera. So um, and first is let's just smile pose. So 3, 2, 1, smile. Okay. The next one is GDSA pose. The two um this one. So 1, 2, 3, smile. Thank you everyone for turning on your cams. And for a while. The next one is get your questions ready as we will now start our question and answer. So you may send your questions in the link flashed on the screen or scan the QR code. I will share the link in the chat box. The same link we used earlier for the word cloud. You may ask questions related to our topic, some clarifications, or even things about generative AI, project management, and more.
Where can I see the questions, Ivan? Or mamaya pa?
Uh, Once the input questions are, it will show here.
Okay, yeah. Okay, I think there's a question. Ivan, how should we proceed in this? Should I read it and answer it, or
I'll just read it for you, sir. So
sige, sige. Thanks, Ivan.
going back to the example, so yung salary prediction after graduation, based on the data along with additional factors that can influence the salary prediction after graduation, like work experience, certifications, industry demand, could you provide guidance on techniques we should apply to incorporate these factors into the model in the context of binary classification po para mas maging accurate yung prediction? For example, 0 for no relevant work experience and 1 for relevant work.
Interesting. Um, was also playing around with this particular problem set. And I think one of the key things na kulang dito is data. Um, did also talk to a couple of my more technical friends, and I think one key lesson here is that despite we have two fronts every time this comes up. So one, improve on our model architecture, improve on our data. You're in the right path. I think this is a great direction to proceed, which is identifying new features such as work experience certification, industry demand, and I'd say you also in the feature engineering part of things, I would like to explore like the correlations between the industry and salary progression. So I know in certain industries have higher salary progression rates than others, and it's part of the job. And if you talk to domain experts, I think that's one of the key insights you look at. So enhance on your the feature set that enhance on the uh, enhance the features that you're selecting, collect more data, and I'd say even a simpler model architecture would work in the particular task. If that's unavailable, use generative AI to generate more data just to have a gauge, and then separate that into training into that data and get a like prediction there. So again, it's not a real world example, but yes, that would show like a key example there. All right. I see a couple questions here. I like this. Is there a link that I can navigate on this one, Ivan?
Uh, I'll just read it for you, sir. It's okay.
Okay.
So the first question is, your thoughts on application of TensorFlow, audio classification, and AI on edge approach?
Hmm. Um, I'm not sure. I'm not aware of this particular part. And thanks for your question. I'm gonna try to look at what that is. But yeah, I'm not the right person to ask for that one.
Thank you, sir. So the next question is, have you tried doing inferencing operation to Android? I tried it and it's inaccurate than TF Lite desktop Python.
Mm, Unfortunately, no. I haven't tried that particular scenario yet. Most of my exploration, and I'm currently still, as a lifelong learner, still developing my skill set here. But most of my applications is around generative AI, and now diving back deeper into machine learning, I'm revisiting computer vision. So most of it is in web apps. Haven't really tried TF Lite. However, I have heard when I talk to my peers, there's quite a bad rap around TensorFlow for similar concerns. And the one of the key insights here is to take a look at focusing it on Keras and other platforms like TensorFlow. Or I should not say that in a Google hosted event, but generally, you learn the craft in TensorFlow. It opens a lot of gates. Particularly, pay attention to Keras. It helps you craft models and get into like wider used frameworks. So I'd say that's one key way to get and like improve that accuracy there. But yeah,
Thank you, sir. So the next question is AI really the future?
yeah. I'm a firm believer of it, and it's just a question of when and how will it actually affect. So one key paradigm to think about here is that software engineering has been a major innovative factor in the past 50 years. So think about the innovations here from custom development, like how it was in its early days, then to like platforms and ecosystems like SAP for corporate use cases. It takes time to change like the industry at a whole. So if you're familiar with the bell curve, there are the innovators and there are innovators, early adopters, uh, late adopters and then laggards, and then late early majority and late majority, and then the laggards. So what's fascinating about AI nowadays is that the barrier of entry has been decreased, and the applications has the the applications of the technology has been increased. So we've seen that in 2023, if you've been paying attention in the startup space, hundreds of startups get funded, hundreds of startups launch and try to solve some problems. You could even say thousands have launched. And one key insight there was from Y Combinator, where they've funded a lot of startups, and in the middle of that particular accelerator group, they shifted their strategy or the use case that they were trying to solve. So AI will be a driving force of the future. I'm not that too efficient, like too delusional to say that it's like the future, that AI will be like humans in the future. I'd say no. At least in the next 10 to in the next couple of decades, it's going to be very hard. And if you think about how long it would take from the early adopters to the laggards, it's decades and centuries. Fortunately or unfortunately, but it will be a driving force of the future. So it's very great to um, get into that as early as now. Yeah.
So thank you so much, sir. So the next question is, what jobs will be replaced or at least mostly replaced by AI? Is programming in danger too? Too?
Yes, this question is related to like the recent popular company that launched Devin, like the AI programming, like the world's first software engineer. I'd say don't, I'm borrowing someone's words here, but don't take a look at its jobs being replaced, but the tasks inside of the jobs being replaced. And when looking at it in like the industry, we are automating a lot of tasks and we're not using AI yet, just plain software engineering and process automation. And a lot of the jobs can be replaced by that already. And there's just a huge hype around AI in this regard due to, how may I say this? It's a new technology that we're still trying to figure it out, like generative AI application. A lot of tasks will be automated, but I don't think it's a major cause for concern, and I don't think it's like the priority of like like, I don't think that it's like the top priority of the governments to address. It is a burning priority, and it should be addressed. I don't want to be mistaken about that, but I'd say sometimes the hype is too much. In the case of AI, it's just the case that it's quite real. We just don't know how or when it's gonna happen. Uh, to summarize my answer, don't think about the jobs being replaced. It's more of like tasks being replaced. And in terms of software engineering, you're not in terms of being a software engineer or a programmer or a designer or product manager, you're not just the task, you're the relationship, you're the expert in that particular field in your company. So once you gain real world experience, you'll see that companies are reliant on people to move. However, also see that there are also some guys who like automate, hey, let's automate the operations department by 50%. And unfortunately, that's part of the work. But you'll see that majority of the categories of tasks, a huge part of it is humans, and I don't think that will be replaced. Programmers would be very difficult to replace because of the human part of it, talking to people, getting what is required, and actually delivering on it. But as majority would say, bad programmers or lazy programmers would need to upskill or be replaced. I think that would be something that uh, would change in this industry quite soon. Yeah.
Uh, Thank you, sir. So the next question is, how does TensorFlow support distributed computing and training across multiple devices or machines?
Mm, uh, quite some hype around this couple quite recently before generative AI, like distributed machine learning. The core technologies behind that I don't understand, but the concepts behind it is very, very interesting. So I'd say it has a lot to do with cloud and just the amount of control Google has over our devices by owning Android and majority of the OSs in, let's say, majority of phones worldwide. I think that my understanding is like it builds on top of that as well as the different layers there. But yeah, I could be wrong. So please take do your own research around this. But yeah, it's very interesting. And I think it's one of the subtle, but would be a bigger part moving forward.
Next question is PyTorch or TensorFlow?
Uh, yeah, this is what I mentioned. I can say this in Google. I was hesitant to say that in a Google sponsored event, but generally, one key thing I've seen is that people learning AI with TensorFlow and Keras, and then uh, getting jobs or industry experience with PyTorch, or just using PyTorch outright because some would argue it's better. And yeah, that's quite the thing.
So the next question is, I think it's a sequence
Wow.
thread.
Yeah,
So
yeah.
the next question is, in learning computer vision, can you describe the learning curve in the field, and will it take a specific time span for learning? I cannot
Mm,
see.
sorry, and learning it as a person. Uh,
Uh, I think it cannot.
should I expand?
Uh, cannot be expanded, sir.
Okay, I'm just gonna take this. Correct me if I'm wrong. Feel free to chat. As how long would it take you to learn computer vision and the learning curve around it? So I really like computer vision. It's one of how I got into the field as well because as humans, we dedicate a huge part of our brain to vision and visualization. So in terms of importance, it's quite crucial. And the first wave of AI innovation is around computer vision. So take a look at the works in early 2000s to um, even the late, uh, even to this day, computer vision has been a crucial part. It's just changed forms into a more, or I say not change forms, just we just added like this layer of generating images and uh, around the field for generative AI. But computer vision, in terms of a learning curve, it really depends on the person and how much time you can dedicate on it. What's great there is thanks to like the footwork that's been done in the past couple decades, it's a lot easier to do. And with the widespread availability of compute and data, it's a lot more fun. Because you don't have to play, if you don't have to do the tedious data engineering and mining, it's great exercise, but it was a lot worse before. It's readily available data and readily available compute unlocks a lot of value for or like makes it easier to learn these particular makes it more fun to learn computer vision, hence I'd say it's faster nowadays than it was before. um but it really depends on the person. And to what extent do you want to learn computer vision? Do you want to stay around in the application layer or down to like the model creation layer? Yeah.
Thank you, sir. So the next question is, what supervised learning technique do you think is the best for recognizing at least three images?
Hmm. Supervised learning technique. um Not sure if I understand the question correctly, but um I'd say it's at least the output is a well, from my understanding here, it's a neural network with a softmax function at the very end. I'm not sure about if it's being the best, but I'd say it would solve the problem for majority of the use cases. And it being supervised means there's a lot of work that has been done already around the data preparation, data engineering, and data cleaning phase. So now your architecture um, can architecture can be uh, and I'm not gonna say quite simpler, but a bit more easier. But if I were to take like a supervised computer vision classification task, I would start with a base model like what I did in the past, like with BGG16 or whatever is the latest version right now, or most widely used version right now. Train this is called transfer learning. I forgot to share about this earlier, but generally use a base model that people have trained a lot of data on already. Train that model to your particular task, classify it in the last three images, and I think you'd have a great result with that already. It really depends on how great you want it to be. But yeah, how accurate or you need it to be.
Thank you, sir. So the next question is, what are your thoughts about Devin?
It's going to be expensive if we don't invest in infrastructure. So, uh, if you've been building generative AI, you can see the API calls pop up with multimodal agents. So, if you have a lot of prompts, a lot of agents, and that you need a lot of context window, it's been made cheaper in 2024 than in 2023. But taking a look at the current pricing and uh, the current pricing and the current limitations of AI, it faces the same challenges ChatGPT has, but a lot they've been more intelligent about it, which is context window. One of the hardest things um, in terms of like transitioning as a full software engineer is the context window. It is a great assistant. So I'd say if it's true, it's claims it's true. I'm waiting for the open release. It's going to be a great assistant to majority of the developers. But as it is right now, it can't replace it because of the limitations on context window, domain expertise, which is a crucial part. Think about like a business that has run for like the past 10 years already. A lot of the technology has been built, and a lot of training has been done to like the current staff, the current software engineering force. You'd need to have a representation of that information, not just for this particular company, but all companies in the industry, or like a representation of that. So context window, domain expertise, and the specifics is where I'd see Devin failing. It's a great innovation. It will be a great assistant, but it's going to be expensive. And I want to know, like, when it's launched, how far can we push it?
Thank you, sir. So the next question is, what are some common challenges or pitfalls beginners might encounter when starting with TensorFlow, and how can they be overcome?
Ah, I'd say unknown unknowns. So if you're starting in a field, not just in AI, you're gonna have to uh, learn a lot of things all at once at the beginning. It's like context switching to a task, but instead of like context switching, you're learning an entire industry. So one common challenges and pitfalls I see, I fall trapped under this as well, is like people diving too deep and not too wide. So people going deep first, too much so that they lose interest in the field. Like, okay, it's too difficult. The math is too difficult. It's too complex. I hate AI. It's too complex. Um, and honestly, you can see how that could go if all of the functions and all of the relationships you need to keep track of, it's going to be difficult to uh, love AI if you take it as a memorization or a learning task in of itself. But there are people who like that, so I'm not going to judge people who like the theoretical stuff more than the practical stuff, and those people push the envelope forward. So I'd say to wrap it up, it's being goal-less, or not having a goal, or starting out. So I'd say one of the key ways to avoid this is to make it your goal to understand the industry, uh, and what you enjoy in it, so that you know where to focus, what's being rewarded there, and what's going in the industry. Go wide and then depth. I'm not saying depth is bad, but if you're starting out in new field, try to understand the basics first for um, what you can understand in the breadth direction. And then if something interests you, go deep relentlessly. So I've in my career and in my interaction with AI, I've dabbled in computer vision, NLP. I like NLP but sucked at it, so I left and did product design and product management. I'm a product of go wide and then go deep. So that's the first that's the first pitfall. The other pitfall is the opposite, which is go wide and never deep. So don't be that person to be a balance of theory and practice. Learn the theory just enough to proceed and apply it. Apply it in any way or form. Try to teach about it, volunteer in some nonprofits, and yeah, um, don't get stuck in that level, like the introductory level. Go deep, go wide and deep, and do both basically.
Thank you, sir. So the next question is, how can machine learning or AI help in digital marketing? So got any tips on what approaches, tools, or tactics or techniques to make the most out of digital marketing plus ML and AI?
I see. Machine learning and ML and AI. Before I'd say generative AI, one of the key things is sensing the market, which is what's in demand and whatnot. There are a lot of tools of it already developed, like from Google and whatnot. Sentiment analysis on your particular brand, understanding what works or what doesn't. Or but I think the biggest boom in machine learning in the biggest boom in AI and machine learning that relates to digital marketing is generative AI. But it comes with a caveat. Just computer generated articles perform significantly worse than human written articles. There's been some studies around this already, and the balance is in the middle. So what's challenging about the digital marketing space, this is more of the content creation, not in the advertisement side, is people don't want to learn AI because there's a stigma around it. Like they're gonna replace me and whatnot, whatnot. Where that's very challenging because like they're the best person to use like the technology. Um, so getting people to adapt like generative AI in the digital marketing roles that you know would have a lot of impact, I'd say, uh, with a short amount of with a short investment, just like a culture change or whatnot. In like the other side of AI, which is advertising, uh, it's quite. This is one of the I think valuable applications of AI, learning about your audience, the feature, the target demographics that works for particular products. Learn about, let's say, this particular product you're trying to sell, like lotion, which demographic work likes this best. With a significant amount of information available, or like generate that to like pixel advertisements and learn through it. Um, a lot of value can be made. Like advertising budgets are millions and billions, and uh, if you can optimize that by 10% or how it's being used right now is actually more aggressive. It's quite valuable, I'd say. So it's it's getting the data and learning the patterns, like which product sells to which demographic, and getting that insight for a company would be quite valuable, I say.
Okay, thank you, sir. So for next question is, for your clothing classification model, so do we need to pre-process outside data for inference, or can we serialize the pre-processor instance for reuse?
Interesting. Can you share us the pre-processor instance for use? Honestly, now I don't know the difference. I want to play around with the model and try both and see the performance uh, if it doesn't break the model. But my understanding right now, and just trying to think about it, I don't know how it would affect the performance, and I want to find out. So thank you for this question. I'm gonna take note of it.
Thank you, sir. So the next question is, what's the minimum amount of data that should be used in machine learning? Are we required to have at least 80% for clarification problem,
I think,
classification problem?
yeah, I'd say it depends on the use case and the performance level that we want it to be. Some industries are a bit tighter in terms of regulations here than others. But there are a lot of best practices that you should follow. Um, I'd say the direction that I go with here is learn about the business problem we're trying to solve, or like the problem that we're trying to solve, and take a look at the existing work. So here is the fun part. You've gone wide. It's time to go deep. Take a look at the paper. Let's say you're trying to classify uh, benign or malignant skin tumors again. Um, Take a look at the work that's been done by other people. That they've published research paper on their methodologies, their models, their data, and their approach there. Learn from it and see if you can improve on it, and use that as a base level. I'm not sure if there's a specific agreed upon uh, level as of the moment, but if it's a classification problem, you should have equal representation in your data set for the classification task. What you'd want to avoid is having, let's say, in a data set of 100, you have like you have like 80 of the class A, 10 of class B, 15 of class B, and 5 of class C. That's something you'd like to avoid in data gathering. And yeah, I do hope I answered your question.
Thank you, sir. So the next question is, what do you think the world will be 5 years from now if AI is growing fast?
I'm When generative AI popped up and the hype was at its peak, I am worried about the Philippines. The reason being is we're a service-based country. If you take a look at our statistics, majority of our income is based on service, not agriculture, and business process outsourcing. As someone who works in process automation, it's quite concerning because I know there's a lot of automation that could be done with just software engineering. Now that we add generative AI for intelligent automation, once we figure out the constraints that we need to put, like uh, how, let's say, how much, like the reliability concerns and whatnot, it's going to make an impact. Uh, my concern is not about the technology, it's about the people. Will we be able to learn fast enough? Will people be able to adapt fast enough, or will there be a crash that's going to happen? I'm more on the optimistic side that people will adapt, but it's quite concerning just for the Philippines. For the entire world, it would, like, take a look at Japan, where their demographics skews towards older people. Generative AI automation would be greatly used in their country kasi they don't have like the entry level workforce. They have too few of them. So they can use process automation to either software engineering based or AI based to alleviate that stress. And that's going to be very helpful. So it depends on the country and the approach. I worry about regulation around AI, but it's going to be exciting. So if there's any time to learn AI, it's now. Um, and yeah, have fun while doing it because it's not gonna change drastically in 5 years, but it's going to change in the future.
Thank you, sir. So next question is, I've noticed that some of your examples are implemented using the sequential API. Can we re-implement them using the functional API?
Hmm. Um, yeah, I think I don't see any reasons that it can't happen. I just did that for simplicity. But yeah, I think there are many ways to improve the models here, and many different ways to approach the problem. So I don't see any problem with that.
So the next question is, how can you integrate a ML model from a notebook, for example, in computer vision, to be used for applications in Android? Is there such API?
Oh, TensorFlow, shown in the videos. TensorFlow I'm not sure about how well it could it performs nowadays, but yes, as Orawa chatted, TF Lite, yes. Um, it made a buzz a couple years back. Not sure if it's still the best technology nowadays, but if you are on TensorFlow, you don't need to learn anything else, and TensorFlow has made it end to end, and you can just use TF Lite.
The next question is, can you recall using eager execution in TensorFlow? When is it best to use lazy loading for eager execution in your environment?
No, not yet. I'm in my journey of going wide in depth. I've read about this, haven't applied it. I'm very excited to use it. Yeah.
The next question is, what is your opinion in AI and its role in relationships such as in AI girlfriends? Can it replace actual relationships?
That's scary. In terms of the psychological effects of it. But it's very interesting because if you look at the OnlyFans industry, there are people being hired in the Philippines to act like the models in like the chat messages for their subscribers. There are also in like applications like Replica, which if you look at their subreddit, it's very very concerning. Um, I'd say there are 99 ways to do this wrong and one way to do it right. I'd say if you can build a model that helps you build relationships, that helps you improve, and I'm not talking about AI relationships, but like an AI model that helps you build human relationships and improves you as a person, I think that would be a great application of it. However, as we've seen in whatever technological innovation we have made as a species, we misuse it around the direction of romance and erotica. So it's going to be quite difficult in that regard. And there are many ways to do it wrong, and as very few way to do it right. So I don't think it would replace actual relationship. I don't think it should in the first place, but it could play a role to make you better in the future. Yeah.
Thank you, sir. So the next question is, when first starting to venture into AI, is it good to learn multiple things simultaneously or learn and master techniques one at a time?
Mm, I'm a firm believer of theory and practice, the power of them together. So I'd say if it's a balance. If you are on a project, if you found something interesting, drop the breadth first search and go deep. If you want to solve that problem, if you want to make an impact, uh, you don't have to like you can stop the breadth first search and do a project based learning. So learn the things you need to do to build that project. But if you don't have a project yet, go breadth first, find what interests you, craft a problem statement there, look for organizations that do that. Omdena is a great platform that has a great selection of machine learning problems that in the real world that you can make an impact towards. So the answer here is a bit more specific, built up on my answer earlier, which is if you have a project, go deep there and drop the breadth for search. If you're still exploring, go breadth, go wide first before you to identify what interests you enough to go over time. I'd say so. Yeah, I think that's a fun way to learn AI, and don't forget to have fun.
Next question is, what job position aside from software engineering or developer is related to machine learning?
Hmm. There are quite a lot. We've shared some in the slides. Depends on your personality. Depends on your personal interests. On the top of my mind, there are product owners, product managers, business analysts, data engineers, data analysts, visualization experts. Um, it's quite that's actually a very interesting field just to like visualize information. Data scientists to help with the pipeline experts, reliability experts, infrastructure experts. The field is quite wide in not in machine learning, and what I'd like you to avoid before you say machine learning is not for me explore or like a specific stack, not just specific to machine learning. Is like explore what interests you in that direction. If you're more design oriented or communication oriented, you might enjoy data visualization. If you're more numbers related or you like looking at data, you might want to focus on data engineering or data analysis or data science. Let's say, um, if you really like building machine learning models, like keeping up to date with that one and fine tuning it towards a specific use case, take a look at machine learning engineering and find what interests you, try it, and build projects or try it at work. If you can't do it at work, go outside of it and build it on your own. And that's one way to discover if it's for you and if you're interested in it.
The second to the last question is, what is your opinion on AI in cybersecurity field?
It's I've in my journey I've also dabbled in cybersecurity. It's a very complex field where it rewards a strong understanding of the whole picture. Uh, Cybersecurity requires a comprehensive understanding of not just breadth but also depth. Um, there are two ways this conversation typically goes. One is AI's impact in cybersecurity. The other is the impact, the cybersecurity concerns in AI. Um, there are many flags that have been raised in the past year and many new security risks that have been raised. Imagine generating a voice to 11 app that matches like a person and trying to be that person towards like a vulnerable audience. That's a malicious application for a generative AI that raises a lot of cybersecurity concerns. The other part is it makes it easier to search for the information that you don't know in cybersecurity as a field that rewards both depth and width of information. Generative AI really works best in that regard, in the unknown unknowns. And if you just have a direction, you can explore it. And it's interesting and concerning. But there are also other concerns in cybersecurity, like increased power in compute, how quantum compute would affect that. I think that's a bigger concern than AI, but both are big changes that needs to happen. So if you're in cybersecurity, that's a very rewarding field if you have the appetite for it. Unfortunately, I don't have the appetite for cybersecurity, but if you are one of the people who are interested in it, try to learn AI and its use cases in the field, and you'll be a superstar. And yeah, I think that's a great way to that's a great takeaway from this.
Next question is, what are your thoughts on the use of AI-generated content in scientific or research papers?
Just negligent. So very irresponsible people using AI wrongly. So it's sad to see. It's sad to see like the negligent use of it. Like you see like in the abstract there are some, hey, this is I can't answer that. I'm sure you've seen some examples of it. It's funny. It's sad at the same time, but it's just people failing to do due diligence. So in one of my examples in generative AI, it's human system interactions that needs to prevail. In personal use cases, um, it has a lot of potential. Again, research is also a field that rewards both wide understanding and deep understanding in the industry. So it can help you understand faster and tackle unknown unknowns, but you have to do your due diligence because of concerns like hallucination and just um, content creation concerns. So one way to do that is use generative AI or like other AI technologies that help you interact with a wide array of information to structure your search for information or direct you, and then direct and then proceed relentlessly in that path. So if you're writing a research paper, You can identify a lot more things faster, but it's very risky because sometimes those are hallucinations. So you have to do the due diligence part after. So uh, the my first impression is like I've seen a lot of negligent use, and I'm sad about that. It gives us a negative rap. But when used properly, you won't even know it's there. But the author is smiling. So yeah,
The second to the last question is, can you recommend Kaggle when first starting to learning ML, DL, and AI?
absolutely. So one thing that actually I'm also in my journey to become more technical. I'm a lifelong learner coming from the business side, and I'd say yes, that's a great platform. There are some courses towards this, and I'll be hosting a study jam session for AI Pilipinas. If you're interested, let me know. Let's dive deep together, and yeah, we can just send me a message if you're interested. It's going to be online, spread across multiple weeks. One of the paths is Kaggle courses and Kaggle datasets, and yes, it's a great platform because it helps you with a significant part of the task for learning MLBL and AI.
The last question is it possible for AI to gain consciousness like humans?
There's as we've explored earlier, there's a uh, dedicated field of research and progress specific to that. Um, I'm more on of the pessimistic side of it before generative AI. I still am, because of the understanding that it's just numbers and neurons, right? But there's this one line that made me think deeper. We don't understand how the brain works, and the way we test for comprehension in students is that we ask you about that particular topic in multiple different directions, write an essay about it, apply it in a different use case, fill in the blanks, multiple choice, and whatnot. And those paint a picture of your understanding. We've been trying to look at AI's understanding by looking at the architecture, looking at the data, the numbers, parameters. Um, I'm not saying that's a wrong approach, but if you evaluate artificial intelligence in the same manner as we evaluate human intelligence, um, we might uh, we might have to look at it differently. Consciousness, on the other hand, is honestly it's a very fascinating part of research, and I think one uh, I've thought about this deeply. One of the things that it lacks is hunger. Um, as humans, we have hunger, we have emotions, and whatnot. It's hard to implement that in an AI model, as we know of today. Um, if you give it hunger, if you give it a way to act, we might be able to first simulate consciousness, then next to have full consciousness before we even know it's fully conscious. So I think the path towards the research there is we're gonna emulate and simulate it, and then suddenly we don't know that it's we already have human consciousness. That might be the direction there. And yeah, I'm very interested about it as well.
So thank you everyone for sending your questions. I hope they were answered by Mr. Gerald John Velarde. So just some announcements. We're preparing something big for next month. So do not miss out on important announcements and updates. So just kindly follow our social media channels. The links are provided in the chat box. Guys, yeah, you may follow us on our social media channels. And with that, this was GDSC CTU's introduction to machine learning with TensorFlow. So on behalf of the GDSC CTU community, I'd like to thank everyone for coming and see you on our next one. Thank you, guys. Thank you, sir.
Thank you. Bye bye. Thanks for having me.
Salamat.